So you'll notice that this point C has two lines that intersect and concurrently meet with point C. Okay, together they make this angle that's called theta, which is a Greek symbol, and you'll be using it a lot in trigonometry, so, or in Algebra 2 trig next year. So, although it looks a little weird and different right now, just bear with me. That's an angle variable that you use a lot. And I guess I can't really spell it out right here, but if you look at question 6 or the solution to question 6 on the group quiz, you'll notice that the question, when we reflect across line L, which went this way, and then we reflected across the y-axis, which went that way, these are both right angles, and they intersect that way. So we had a shape that, whatever looks like that, reflected it one way, and then we reflected it this way as well. And if this point started out here, then it ended up 180 degrees the other way, which is 2 times 90 degrees. So if these intersecting lines are theta degrees, this entire thing is 2 theta. So if my theta was 60 degrees, this entire thing is 120 degrees, and that's how far it rotated. So two reflections are the same thing. Two reflections with intersecting axes of symmetry is the same thing as a rotation about that point which they meet. Okay, and how many degrees is it? Well, it's twice the amount of the degrees that the intersections make. Okay. Okay, now I'll give you some different terms here. The word orientation, and we'll talk about it a little bit as we see more images. It's the way that a figure's order of makeup is perceived. Now, those words might not really make too much sense here, but let me go back to the very first slide. If I look at this right here, this point right here on G and this point right here on G, they're both looked at on the right side of the figure, if that makes sense. Or if I took this G and brought it back upright again, this point would be on the right side, same with this G. So translations and rotations, they have what's called the same orientation from pre-image to image. They all count things the same way. Or to put it another way, let's say I had a shape here, like a parallelogram, well, like a shape that looks like that, and it's A, B, C, D. And I have A prime, B prime, C prime, D prime. D prime to A prime always goes this way, left to right, or if it was rotated like this way a little bit, it would go down to up, etc. They would be in this order. Not like this, where if I look at a reflection, these G's face each other. Okay, there was some mirror image that took place. So I think the best way to put it is that if something has the same orientation, that means the image is not flipped. Okay, if you see this glide reflection here, when it translates first, it has the same orientation from here to here. When it reflects over this line, no longer do these or these have the same orientation. Something got flipped, something got changed in order. So the way that the thing is made up, the order that we perceive it in, gets changed around. That means it has different orientation. When it's not changed around, even if we rotate it and such, they still have that same order. We still draw G that way and we just rotate the paper. That means it has same orientation. So we'll see a few examples. So we use the word orientation for these two things, direct isometry and opposite isometry. So we know that isometry means congruent, pre-image, and image. Okay, but a direct isometry means that the pre-image and image have the same orientation. Okay, so translation and rotation, again, going back. Okay, all of these images are congruent. This G is congruent with this G, but the thing is they don't have the same orientation. Whereas translation, they're congruent and they do have the same orientation. Rotation, they're congruent and they do have the same orientation. And glide reflection, again, we'll learn about. Congruent, but a different orientation. Once it gets flipped, the orientation changed. So that's direct isometry. And opposite isometry, which I'll go back to, are glide reflection and reflection. They have opposite isometry because they have different orientations. They do not have the same orientation. Okay, glide reflection. So you kind of just saw it, and I'll probably just use the same example. It's a translation followed by a reflection. So first we translate this image. I'll just go ahead and move that over there. I take that and I have a new F over here. And then I reflect it over a line like so. And pardon me for not color coding this. But there we go. So just like that G that you saw earlier, there's my F. Now, the translation must run parallelly to the reflection axis of symmetry. Okay, so this line has to be parallel with that line to be considered a glide reflection. So you might see some translations that are slanted. For example, I might see one that looks like that. So that means its axis of symmetry also needs to be running parallel to it. So if I did this, translated, whoops. If I did this and translated it up here, then the reflection would end up looking a little different. It would probably look more like that. Okay. So that's a glide reflection. And a glide reflection is a composition of 3 reflections. Because if you remember, a translation is 2 reflections, right? It's a reflection across, say, this line and this line. And they run parallelly. 1, 2 reflections, and a 3rd reflection. And just so you know, from any image to any other image that are isometric, you need as many as 3 reflections ever. You never need more than 3 reflections. You either need 2 to translate and 1 to reflect, or 2 to rotate and 1 to reflect, or just 2 to translate and 2 to rotate, which is kind of a cool thing. It's actually a theorem in your book. I think it's theorem 12.4. Okay, examples of glide reflections. First I want to translate or glide. They're both the same. Let me write that. Translate, glide, same thing. This should be triangle MNO. Triangle MNO over, or by 0, -5. So 0 is your X, -5 is your Y. So that means I want to lower all of these. There we go. I want to lower all of these down 5. So they go 0 in the X direction. Each point, I'll lower 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you can use matrices for this if they ask you to, or if we ask you to. Otherwise, for right now, I just want you to be able to do that. And I'll go ahead and clone it. Why does it always do that? And drag it on down here. Okay, and that could be M prime, N prime, O prime, for instance. Well, I'm not going to bother with that. So that'll be M prime, N prime, O prime. I think this thing gets messed up with screen capture. Anyway, next part. One sec. Okay, just making sure I'm still recording. Anyway, the next part here, let's make this a different color. God. Next part is reflecting it. So let's reflect it over x equals 0. Now you should know by now what that is. If not, you really have to study up on it. It's for every y, you have a 0 for x. So reflecting it over that, n prime, which I'll call it, needs to reflect 1, and over there, I'll just go and mark dots for this one. N prime, or double prime, O double prime should be right here, and M double prime should be right here. And I'll just take that, copy, paste in, drag over, and flip. Of course, you have to draw all these, so just kind of go in shorthand for you. And as the other ones, I'll make it blue. So there's your final result. I did a glide and a reflection. Now they will ask you, when they say to translate or glide, these should run parallel to the axis which you are doing this over. You are reflecting this over. So if they are not, then you should ask a question about that because something's wrong. Now, you might have an example